So it's the Sunday before your paper one tomorrow, and I just want to give you some last minute stuff to have a think about. I know we've done some of this week. I'll also go into a little bit more detail on the higher tier stuff at the end of this, which we didn't get a chance to do in class. So yeah, all the things in the first half of this I would expect to be in the first half or around up to halfway, maybe just after halfway, and then everything that's higher tier I'd expect to be towards the end. Okay, so expressing numbers as product of prime factors. I'm not going into the whole question, just remember the pen is, as we know, this pen isn't great. To set your workings out like that, okay? And you're looking to divide these numbers, I guess, by 2, 3, 5, 7. That should be enough. You might be left with something like an 11 at the end. You might, but unlikely. Yeah. In order to be a square number, okay, I think the answer to this, and again, apologies if I'm wrong, is something like this. Well, let's work it out. 4 times 9 is 36. No, it's not that at all, is it? I'm probably better off just doing it. Totally wrong. Yeah, sorry, that's a 5 squared times 7. Okay, like if it said to you, okay, is this a square number? Well, every single indice will have to be even for it to be a square number. Now, 2 of them are, but because the 7 isn't, this is not a squared number. Okay, if it asked this, I don't think it will, but if it did. However, it might then say, okay, what would you have to times the 700 by to make it a square number? Well, we'd need to up that power another one. So if we times the answer by 7, then not only would the 2 be squared, the 3 be squared, but now the 7 would be squared, so we would have a square number. And it's the same reason here. This isn't a square number because this is an odd indice, whereas square numbers have even indices. Talking about indices, we're in the first half of the paper still, so we can't, like, I saw a couple of people do things like this. No. Okay. You can only add the indices if the numbers were the same, first of all, and these aren't. So if it was this, yeah, absolutely, that could be simplified to that. But in that case, the number would stay the same anyway. It would still be 3. So different numbers. This is, and the clue here is calculate, which means give an answer to, work out. So it's 27 times 100. Nothing else to say there. Just give your answers if you get questions like that. Okay. Standard form, nothing to say. Remember, if you're timesing or dividing, okay, do it in standard form. So here, divide those numbers and then divide those numbers. If you're timesing, you add the little indices on the tens, and if you're dividing, take them away. Whereas adding and taking away, I would do as numbers. Let's move on. I think you're okay with Venn diagrams. That's not a problem. Here, straight lines. Before we can say what the gradient or y-intercept of a line is, it needs to be y equals something x plus or minus, I guess. There's something on the end there, which this is not. It's 2y equals that. So I would have to divide both these by 2. So 5 divided by 2 is 2.5, and 4 divided by 2 is 2. So the gradient of this line is 2.5, and this line also has a gradient of 2.5. This one is asking about intersecting the y-axis. It's talking about intersecting the y-axis. The y-intercept or y-intersect, basically meaning the same thing, aren't they? So what other line intersects the y-axis at the same point? Well, this one intersects the y-axis at -5. So what other line does that? This one here also intersects the y-axis at -5. Here, we're asking which line could this be? Well, all I can work out from here is that this, I've got the y equals, which is nice, but this has got a negative gradient. So I'm looking for it to be coming like that. And it cuts through the y-axis. The y-intercept is +3, which is here. So it's either A or D, and of those two, it's D, because D has the negative gradient. Be careful. The other thing that's not included here, obviously, is we haven't talked about perpendicular lines. So if I was asked, for example, here, what is the gradient of a line perpendicular to this line, okay, then I would flip the sign and take the reciprocal of the number. Okay, so that would be the gradient of the perpendicular line to that. Nothing to say. Factorising, okay, not quadratics, okay, because you've got x's, you've got y, it's just not. It's a single bracket, so take a 3 and an x out. What you're left with, 4x plus y. We did this all the other day, so I'm going to rush through these. Nothing to say on solving. Changing the subject of the formula. We're still in the intermediate part, so if you got this earlier on, you won't need to factorise. So you will need to expand brackets. Keep the subject terms one side, which in this case is x is going to be the subject. Take everything else over. Okay, so there was a plus 2y here, but I'm going to take it over here as minus 2y, and I know I'm jumping steps here, but x equals, well, I can simplify this to 5y minus 3, but also then divide by what that 2, which was times in that x, which is now there. Inequalities we did a little bit in class. Remember, you know, you're looking, one thing to say is whatever way your inequality is, just keep it like that. Don't change it to an equals. Just keep it until you get either n equals something, or vice versa. It could be n on this side and your answer over here. It doesn't matter. Okay. Ask me about that if there's any problem. Send me messages. Here, if you've got two parallel lines and you're talking about angles, if this comes up, what we end up with is two groups that are the same. So they are opposite each other. So a useful phrase for you, opposite. And these, you would take the 113 from 180 to get 67. Sorry, it looks like 57. 67. Therefore, A is in the same position as 113. C is in the same position as 113, but B is in the same position as the 67. Pythag, nasty, just because it became 289 at the end. It could well say, though, leave your answer as a third and simplify it. That wouldn't be nice to your mind, trying to find two numbers at times to give that. And actually, in this case, it doesn't. It's actually looking for me to work this out. Just take your time. Is it 15 times 15? No, it's more than that. Is it 20 times 20? No, that's 400, so it's less than that. And I'm sure you can get there in the end. Okay. Trigonometry coming up, but we know we haven't got calculators, so hopefully they'll give us a bit of info like that to allow us to do it without a calculator. That's what we're hoping anyway, if it comes up. Dimensions, remember, get rid of numbers and get rid of pi. So the 2 and the pi there can go, the pi there can go. Let me zoom in a bit more on this one. Can I zoom in? Yeah, okay. What are the numbers? Oh, I've got a 3.14 there, get rid of that. And then look at each term separately and decide if each term is a length, volume, or area. So d squared is an area, hw is an area, so that's an area. Write it in full though. D is a length, w is a length, h is a length, so that's a length. R is a length, but r squared is an area, so that's a mishmash, so it's nothing. Expand the brackets here, dw plus hw, both areas. D cubed is a volume, dwh is a volume, so that's a volume. I will mention circle theorems for a little minute because there are quite a few of them, and I'll try and go through them all again with you, okay? We know that the alternate segment theorem one won't come up. That will come up on Wednesday if it indeed does come up, okay? But all the others can. So the ones that we're using here is this. These lines that come along and touch the circle at a point are called tangents. We've got two tangents here coming from the same point, P. And the first circle theorem is two tangents from the same point are equal in length, okay? So when it says what is the length of PA, you can write, well, P to A is 12 because two tangents from the same point are equal in length. Second circle theorem, if you've got a tangent and then it goes from where it hits the circle up to the middle, it's like a radius, that makes a 90-degree angle. So does this one. So what is the size of P to A to O? It's 90, and my theorem is where a tangent meets a radius, or a tangent and a radius meet at 90 degrees. So circle theorem 2, okay? Calculate the area of the quadrilateral. Well, what we've got is two right-angled triangles. Now, this gives us options, doesn't it? It could be an area question, like it is here. So base times height divided by 2, okay? With a base of 12 and a height of 4. And then a repeat for the second triangle. It could, you'd have asked me for the length of PO, which is a chance to do a bit of Pythagoras theorem on here. I doubt trigonometry linked with circle theorems, but who knows? It's kind of like hiding right angle triangles in other questions to allow you to do Pythagorean trig. Oh, who knows, okay? The other circle theorems to be aware of are looking for that bow tie where they are equal, and the theorem is angles on the circumference, because that's what you'd have here. I'm not drawing the whole thing, all right? Angles on the circumference, or maybe I will, just badly. Angles on the circumference are equal. So the two on the top of the circumference are equal, the two on the bottom of the circumference are equal, and also these two are equal, nothing to do with circle theorems, they're equal because they're opposite each other. So that's the bow tie one. We've got the arrowhead one, which looks something like that. And this one is that the angle at the centre is double the angle on the circumference. If it asks for the reflex angle at the centre, okay, let me just show this a bit better. Because there's two angles at the centre, isn't there? There's this angle at the centre, but there's also this one, right? This one is the obtuse angle at the centre, but if it asks for the reflex one, it wants the other one, so you'll have to take that one away from 360 to get the rest, the reflex angle. What other ones? Oh, the cyclic quadrilateral. We're looking for a four-sided shape. 1, 2, 3, 4, where opposite angles add up to 180 in the cyclic quadrilateral. And the final one to look out for is the semicircle. So if we've got a line all the way across the circle through the centre and we make a triangle there, then that angle is 90 because an angle in a semicircle is 90. So that's all your theorems for tomorrow. Just try and apply them and hope for a nice question. Construction, I don't want to talk about the top one, just a reminder, ladies and gents, if I wanted to construct a 60-degree angle, okay, first of all, draw the line. So let's go with 8 centimeters, use a ruler. And then open your compass up, and from there, line up, boom. And then put the sharp at that end and draw it the other direction. And where they cross, if you connect that to there, you get a 60. But also, if you connect it to the other side of the line down there, you get a 60 there. And then to cut that in half, put the sharp bit on the end here again, open it up a little bit and start drawing a circle around the end there, okay? And where that circle touches those two lines, we start drawing circles around there as well. So one around that circle and one around that point, sorry. And where they cross, that splits the angle in half, but do a better job than that, okay? And leave all your arcs, as they call it, on the, because they are your workings out. Perimeter. The perimeter of the square is 28, not the area, the perimeter. So all I've got to do is divide that by 4 to know that that's 7. Okay, do a better job at this. So whenever you'll get an OCW question tomorrow, whatever you're doing, say what you're doing. Okay, so here I've got bullet point. The length of the square is 7 centimeters because 28 divided by 4 equals 7 centimeters. Give you units. Okay. The area of the triangle is 35 centimeters squared. Therefore, the length of DE, and I'm, bullet point this, is equal to, and basically, guys, different people do this different ways, but one way to do it with a triangle is to double the area and divide it by the base. Yeah. And we're talking about a length, and the length of DE, so that, but yeah, OCW, bullet points, units, be, methodical in the way that you work. Again, I don't want to talk about this one because we did it in class, but yeah, let's move on. Averages, numbers to be written on the blank card. The mode and median of the 7 numbers are the same. Find one possible number that can be written on the blank card. Oh, I've done this one before. 5 9. I'm just putting them in order because we always have to write numbers in order when we're talking about averages. That's interesting, isn't it? Okay, at the moment, right? Oh, very interesting. At the moment, the median is between those two numbers. However, if I add an extra number somewhere, I'm then going to have 7 numbers. So the median will be the fourth number, the number in the middle. Okay. If I need the mode and median to be the same, okay, then the number that I add in there to be the median needs to be one of these two numbers. So I guess your options are 11 and 18. If I put 11 there, the mode is now 11 because there's more than one 11, and 11 is also in the middle. But alternatively, I could have put 18 so that there's more than one 18, and 18 is in the middle. Okay, so I'll give the answer 11, but they've two answers there. Okay, this is about the mean. The mean of these numbers is 27 divided by 3. At the moment, the mean of these three numbers is 9. I want the mean to be 1 less than this, so I want it to be 8 by adding a fourth number. But if the mean needs to be 8, there are now 4 numbers, and 4 8s are 32. Okay, so I'm going to need the numbers to add up to 32. Well, they currently add up to 27, so I need 5 more to make them add up to 32. I don't think you're going to get a tree diagram, if I'm honest. I think that this, what with this in the list, is probably more likely to link to Venn diagrams, and I think the tree diagrams will be the second paper. However, just in case, the probability of A and B occurring is 0.48, so they've kind of worked out the combination for you. So if I work backwards and divide by 6, I get that to be 0.8, and I can start filling that in then. Okay. The chances of, remember in a tree diagram, again, I don't want to go overboard because I don't think you'll get one until paper 2, but imagine a times line there. So if you want this followed by this, you times those two numbers together. So here, it'll be this times this to get your answer done there. Right, and we're finally into the higher tier stuff. So, the cube root of 8 is 2. That's that bit done. 2 to the power 4 is 16. That's that bit done. And put your answer 1 over it, and that's the negative part dealt with. So minus means 1 or the reciprocal of. Here, 512. Take away from that the non-recurring digit, and over 9 for every recurring digit, the 1 and the 2, and 0 for the non-recurrer. So 507 over 990, and they rarely ask you to simplify it, if ever. Okay, direct and inverse proportion, we end up with F equals K because it's inversely proportional to the square of D. You then have to find what K is. I'm not going to do it now, by putting in that value for F and that value for D, and you get it to be 200 over D squared, and that's your final answer there. Okay, you try those because we did them in class. We also did these in class, but let's remind ourselves. A minus outside, a minus at the start is a reflection, and that's a reflection in the x-axis. So this point would come down to there and it would reflect. A +4 outside the bracket is a movement up. A minus inside the bracket is a reflection this way. And a +5 inside the bracket, so anything inside the bracket is a left or right, or reflection left or right. So the +5, it has the opposite effect and it moves it left 5. I should have put that this was a 4. Didn't do this one in class, so here we go. Y, x minus 8. So if ever we got something like this to solve or to change the subject of the formula or anything with an equals, we've got to get rid of that fraction. Whatever's on the bottom needs to go into brackets and up to times the other side. Okay, we'll do that. we're trying to make x the subject of the formula, so I'm going to bring anything with an x this side, okay? Anything else, and all we're doing here is, there's no times in becoming divide, nothing like that, right? Nothing like that happens till the end of anything like this, whether you're solving or changing that. It's all minuses, minus terms becoming plus terms, or plus terms becoming minus terms. So the minus 8y goes to the other side and is now plus 8y. No dividing, just moving things from pluses to minuses, etc. Now, the reason that this is higher and it's at the end of the paper, not the start, is because we will need to factorise here. We need to take the x outside a bracket, and we're left with y minus 1. And then that x stays, and what it's times in by, well, kind of the opposite of what we did at the start, I guess. The times goes down as a divide by that bracket. Right. Really similar looking thing to this. Yeah, really similar, but we're solving, not changing the subject, because there's only one letter involved. So get rid of the fraction, up you go as a times. It might be useful to put that in brackets as well, so that when that comes up there, it's that. So we're left with 25 equals, and if you do your FOIL, which again all of you are really good at, we get m squared plus, after you've simplified it, 6m plus 9. And then you go, right, actually, to solve this, this is a quadratic, this isn't a linear equation, so I need everything one side. Well, seeing the quadratic at the moment is over on the right, let's leave it there, because the only thing that needs to come over is the plus 25, and we'll take it away from the 9 to give minus 16. And then looking for two numbers that times to give minus 16, that add or take away to give the number in the middle, which is plus 6. And my two numbers here are 8 times 2 and 8 take away 2. And it works because if the 8 is plus and the 2 is minus, then they would times to make the negative I want. Great. So to factorize it, we get m plus 8, m minus 2. I should have, I'll keep that in there. So either that bracket equals 0, or that bracket equals 0. One of those two brackets needs to equal to 0. Therefore, m is equal to, take the plus 8 over here to be minus 8, or take the minus 2 over here to be plus 2. This, much harder. Why? Because there's not one fraction. We can't, because what you can't do here is go, oh, the opposite of dividing by this is the time, but you can't do that twice with two different fractions. You have to make them into one fraction by doing the top of that times the bottom of that, plus, because that's what we have here, if that was minus, that would be minus, the top of the right hand one times the bottom of that, divided by the bottoms times together, x plus 2, 2x minus 5 equals 3. Now it looks a bit like this, but just a lot more work in it, okay? We can expand that single bracket, we can expand that single bracket and simplify that. We can expand here using FOIL, smiley face, alright? And I'm not going to say any more than this. If you want to come in the morning early, and I'll go through this if you're struggling to see it through to completion. But the opposite then of dividing by the bottom of this fraction, just like up here, is to move whatever that becomes up and times by it. So whatever is there will go up there in a single bracket and times by it. The idea is to bring everything to one side so that we make this eventually look like a quadratic, okay? Then we can factorize and solve it, but there's just a lot more work to do. The other problem you're going to have here is your quadratic isn't going to be an easy one. It's going to be one that has a number here. It's going to be something, I won't even make up what it is. Have a go. Okay. Y equals x is what I'm going to draw. If I had a little table, if x is 0, y is 0, because they're equal. If x is 1, y is 1. If x is 2, y is 2, because that's what I'm drawing. So 1, 1, 0, 0, and 2, 2. Not, this isn't going to look great, but okay, something like that. Okay. Second line, y equals 1. Y equals 1. It goes against all your better judgment here, because you're going to think, oh, I need to draw a y line, which is up, but no, a y line is a cross. Label them if you want as well. That is me drawing y equals 1. This is me drawing y equals x. And then we've got the slightly more difficult one. Let's plop some x values in. 0, 1, and 2. Never use the negative values, okay? And then the y would be equal to, well, there's a couple of ways to do this. They've got to add up to 4, haven't they? So nothing, add 4, 1, add 3, 2, add 2. 0, 4, 1, 3, and 2, 2 is a matching point there, and down they come. Oops. And then shade in the triangle. I should stop there really, but yeah, shade in the triangle that makes, okay? Congruence. Congruence. 3 things that prove congruence. 3 equal sides in the same position, so in the same order going around the triangle, okay? Side, angle, side with the angle enclosed between the two sides, or angle, side, angle with the side enclosed. However, bear in mind that if you actually know 2 angles in a triangle, you know all 3. What isn't a condition is angle, 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 which means the triangles are similar and may be congruent. Similar means one could be an enlarged, a bigger version of the other, so they are similar shapes, but they might be congruent, they might be identical, but they might not be. Whereas these 3 mean they are identical, okay? So in the first one, I've got a side, angle, side, side, angle, side. So my condition is side, angle, side. If you wanted a bit more wordiness, if they wanted to say, to describe it, you'd say both have 2 equal sides with the same enclosed angle, or something like that. Here, side, 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 and they're in the same order. 6.5, round to 14, round to 10. 6.5, right? It doesn't matter here that we're going in reverse, right? It doesn't matter the direction. That's okay, right? They are side, side, side. 3 sides the same, in other words. And this one, you'd look and go, ooh, no, not quite, because it doesn't, the side isn't enclosed between the angles, otherwise it would be there. But, like I said, if you know 80 and 25, then you know that that is 75. And you can work out again that that is 75. And so always be careful that if you know 2 angles, you know all 3. Therefore, you have got angle, side, angle, and here, angle, side, angle. Okay, so A, S, A. Trig graphs, okay. The cos one starts at 1, comes down to 0, goes down to -1. Be neat if you have to draw this, okay. Look at this now. Look at how it's set up here. You've got to make it look the same, and it doesn't. It's not it's not like straight lines. It's curves. Boom. Do each bit separately. Curve. This is the valley bit. Curve, and then curve. If it was the sine, it would start there and do that instead. Okay. Right. Given that one answer to this is 40, or they could have just written the 40 in there. They could have said, given that cos 40 equals. In other words, where this is 0.766, that is 40. Okay. The other answer then to this is here, but you need to realise, hang on a minute, that 40 gap is there if you look at the symmetry of this. So the other answer is 360 take 40, so 320. I don't really understand why they asked you for 200 here. If I was them, okay, I would have asked for, and I think this might be a misprint, I would have asked for 220, and here's why. 220 has a gap there of 40, and because we're kind of coming from away from the x-axis towards it, if you can see what I mean, then that is just the negative version. So the answer to that then would be minus 0.766. I don't really understand. We haven't got any info about 200. It would just be an estimate. Anyway, enlargement, minus 2 and 0.6. So every point, okay, has to be twice as far away from that in the other direction. That's what the minus means, the other direction. So to get to this point here, it's 2 left, 2 up. Twice as far away in the opposite direction would be 4 right and 4 down. To get to this point, it's 4 left and 1 up. The opposite direction would be 1, 2, 3, 4, 5, 6, 7, 8, and 2 down. So that's that line there. To get to there, it's 2 left and 4 up. So we're going to go 4 right and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And you can do that for the last point then as well. But I think at that point you'll probably see, oh, hang on, it's there. Twice as big in the opposite direction. Alternatively, they could have drawn this, okay, and ask you what's going on here, and you'd have said, oh, this is an enlargement, and you could use these to kind of find your center of enlargement, and then you'd have seen, oh, to get from A to B, it's twice as far in the opposite direction, and you could describe enlargement, minus 2 is the scale factor, 0.6 is the center of enlargement, and do it that way. Higher level surface area volume, so things like cones, pyramids, and spheres, okay, all given in the front of the book. Be careful that it doesn't give this one. However, for the cone, it's something like 1/3 pi r squared times the height, I think. Sorry if I made this up, right? If it's a pyramid, all you have to do to get the volume of a pyramid is replace the pi r squared, which is the circle at the bottom of the cone, times the area of whatever shape is at the bottom of the pyramid, so normally a square. Right, I know that doesn't look like a square, it will in 3 dimensions though, right? So the area of the square there times the height, okay? And then the sphere, so go looking for these, right? This one is talking about the surface area of the cone. Now, when you look for that one, you will find that the surface area of the curve in the front of your book in your formula sheet is given by that, where this is the radius and this is the length, not the height, the length of the side, okay? However, that is just the curved area. The surface here is not just the curve, there's the bottom as well. Think of all the different surfaces you can see here, which is a circle. So what we end up with is pi times the radius 4 times the length, which is y. I don't know why I wrote the times in, I don't normally do I? Okay. Plus the bottom, which is pi times the radius squared. And we're told that the answer to the surface area is 48 pi. Now, because pi is in everything I can see there, I can go, forget that. So I'm left with just the 4 times the y here, and just 16 here, 4 squared, equals 48. And now I've just got myself a nice little linear equation where numbers go one side, so the opposite of plus 16 is minus 16, so that's 32. So y is 32 divided by 4, which is 8. And finally, conditional probability. Okay. Remember combinations. List them. How many does it want? So I'm going to start with one that's not here. What is the probability of getting a t, then a t? Okay. So initially there are 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are t. But if I don't put it back, if it's without replacement, there is then 1 out of 10 times the tops times the bottom. Don't simplify, right? Okay. Then we might get something harder. What's the probability of getting 2 letters the same? So it could be a T followed by a T, or it could be an M followed by an M in this case. Are there any other letters? or an A followed by an A, work them all out and add them all together, okay? Or something like this, which is a bit harder. Calculate the probability that exactly one M is taken from the bag. Right, exactly one. Think about this. Is M then 1M? No, it would be 2, okay? So what I want is an M, but if I get an M the first time, I don't want an M the second time. So rather than listing the millions of combinations, like, oh, it could be an M with an A, or an M with a T, or an M with a H, or an M, you'll be there all day. So anything that is not M, call it exactly that. Or I could not get the M first time and get it the second time. So to get an M is 2 out of 11, followed by not getting an M. Well, there are 9 letters that are not M out of, if I've already taken a letter, 10. So that's 18 out of 110. Or not M to begin with, so 9 out of 11. And then if I want an M the second time, there are 2 left, but out of 10. So again, it's the same answer here. But because there's more than one way to get what I need here, the OR means I have to add together my combos for 36. Now, remember what we said about this, okay? Some of the wording that they like to use is at least 1M. This is a slightly different thing, okay? At least 1M. At least 1M. So what you might want to do for at least 1M, slightly different thing, is go, actually, I will do, this is 1M, I will do the complete opposite of this. I will do no M's. So I will work out not M, okay? So there's 9 out of 11 initially, followed by 8 out of 10, which is 72 out of 110. However, that is the probability of having no M's at all. Every other probability includes either 1M or 2M's in this case, which would be allowed, okay? So take the 72 away from 110, so the chances of getting at least 1M would be 38. And notice I'm not simplifying at all, okay? So that's quite a common one. At least one of something, work out the opposite. Group things, not M. Or if it's vowels and consonants, not consonants. Or if it's blues, reds, greens, and yellows, blues and not blues. Whatever they're talking about, everything else becomes not that thing. I don't really want to talk about this, okay? I just want to say that the other way to get a quadratic to solve, okay, one way is like with these algebraic fractions, okay, where you kind of rearrange them and you get your quadratics like that. The other way is like a part A and a part B, where part A is to prove the quadratic is the right thing for the question, and then part B is the find x, which is another way of saying solve. Okay, so this is where you would do your factorizing, not in part A. Part A doesn't say solve, part A just says prove it, so we've got to like look at the picture or read the writing or do something and work with it, okay? And it might be difficult, part A, it might, like this one is really, really hard, okay? It's linked. I've never seen anything like this, mind. There are X apples in a crate, and 4 of them are bad. 1, 2, 3, 4, okay? Fiona chooses 2 apples without replacement, so this is kind of thing saying it's a probability question. What are the probability that she gets 2 bad apples? Well, initially there are 4 bad apples out of X apples in the bag, followed by another bad, so bad followed by bad. There's now only 3 bad apples left, but there's not X left in the bag anymore. There's X, take away 1. Times in, okay, you just literally times the tops and times the bottoms. Think of that as being in a bracket and times them both by X, okay? But we're told that the probability of that happening is 1 over 11. Now look at the answer and go, oh, hang on, then where are these numbers coming from? I can see the x squared minus x. Oh, hang on. If this is being divided by, my gut feeling says it should come up there and be times by it. But we've actually got a fraction the other side, so that 11 can go up there and times by that as well. So you get 132 equals x squared minus x, which is almost that. To make it that, if I took the 132 over that way, I'd end up with 0 equals x squared minus x minus 132. Then I get to solve, hurrah. X, this is an easier quadratic because it doesn't have a number at the start, so this should be okay. All right, I'm looking for two numbers that will times to give 132, that will add or take away to give this middle number here. What number's before there? It's actually minus 1, nasty. Actually 12 times 11 is my best bet. Okay, 12 times 11. To get minus 1, it's 11 take away 12, or minus 12 add, because we've got to get that minus there. And does that work? Yes, because if that's negative and that's positive, they would times to give me the minus 132, which is what I needed. Okay, so into there, plus 11 minus 12. But we know that this is equal to 0, so we can then say, okay, x plus 11 equals 0, or x minus 12 equals 0. So x equals minus 11, or x equals 12. And always don't forget that word, okay? It's either this or it's this. You'll always get two answers for quadratics, okay? And that is it. Thank you very, very, very much. Good luck. I'll see you in the morning. All the best with your revision today.